Alright, today we're going to take notes on the accessory organs of the dermis. As you take notes, you need to also answer the questions embedded in this video, as well as coloring in the sheet provided to you. You can go ahead and just color it when I tell you to color it, I suppose, but the same coloring system kind of as your coloring sheet last week. You're going to color code the boxes next to each term, and then you're going to color in the picture on with the same color, or color in the accessory organ in the picture with these colors. All right, so accessory organs. We're going to start with the nails. You're going to see there's no nails in the picture, so go ahead and just take notes on this guy. Your nails, like fingernails and toenails, are protective coverings for the ends of your fingers and toes. They consist of the nail plate, which is composed of tiny keratinized scales that overlie the surface of the skin called the nail bed. So you have the nail plate, which is your nail, over the nail bed, which is the skin underneath. That little white half moon portion in the back of the nail bed, or the proximal end, is called the lunula. This covers the actively growing region of the nail. So there's three terms right there that you need to know. Those are good terms for flashcards: the nail plate, the nail bed, and the lunula. The nails are produced by specialized epithelial cells. So back by that cuticle, special cells back there that make these keratinized scales that consist of the nail plate. I'm pretty sure I don't have a picture here, but pretty sure there's a picture in chapter 4 of your textbook, or you can look it up. If you're taking notes online, I would highly suggest that you add a picture of the nail, and that is labeled with the nail plate, nail bed, lunula. Okay, moving on to hair follicles. This is in your picture. I believe it says hair shaft and hair root. It gives you color. So the hair shaft should be black, and you color that black, and the hair root purple. The hair follicle and the hair root, not exactly the same thing, but pretty much the same thing. The hair follicle is an invagination of the epidermis in which hair is formed. So it's still part of the epidermis technically. So it comes down through the epidermis into the dermis. It contains the hair root. You have hair follicles all over your skin except for, and you'll need to remember that you don't have hair follicles on your palms, on your soles, so palms of hands, soles of feet, or on your lips or nipples. And when it says that, like right on the areola part of the nipple. You also do not have hair follicles on the external reproductive organs. The epidermal cells at the base of the hair follicle are nourished by dermal blood vessels that keeps them nourished so that they can keep creating new hair. The hair shaft is composed of keratinized dead cells. So specialized cells in the hair follicle are going to make keratinized dead cells. That is the hair shaft. Hair distribution is influenced by sex hormones. So where you have hair, how much hair you have, how thick it is, influenced by sex hormones. The hair color is determined by the type of melanin that is produced in the hair follicle. And red hair pigment is called trichocerin. You don't need to remember that, but that's an interesting fact. And I'm pretty sure there's some iron pigments or like iron in there to give it that red color. Let's go back and take a look at my picture of the dermis here. There it is. So you have the hair shaft, which is the hair itself, and it's inside the hair follicle. which is part of the epidermis. You can see it's the same color. There's the epidermis. All right, moving on. We have more about hair. The erector pili is a muscle connected to each hair follicle. It's smooth muscle. It causes the hair to stand up when a person is cold or upset, like when you get the goosebumps. It's on the side of the hair follicle. And you have that on your picture in color, the erector pili brown. And it's actually kind of shaded in black already, so go over it with brown. Take a look at it in our picture. Here it's red in the picture, the erector pili muscle. So part of it's attached to the epidermis, the other part to the hair follicle. So what's going to happen is this muscle here is going to shorten. When it shortens, it pulls on this hair follicle. Well, the hair follicle will move this way, and in turn the hair will stand up. And it creates, happens when you get goosebumps. So that muscle is called the erector pili muscle. You need to know that. Should be underlined here, so make sure you have it highlighted or whatever in your notes. It'd be a good one for flashcards. Next, accessory organs, the sebaceous gland. The sebaceous gland is the anatomical term for the oil gland. It's a type of holocrine gland, which we learned about with the epithelial tissue. It secretes a product called sebum. So sebum, sebaceous gland. Sebum is an oily mixture of fatty material and cellular debris. Keeps hair and skin soft, pliable, and waterproof. So we probably should have that underlined. Sebum is another term you need to know as well, sebaceous glands. So sebum is actually good for your skin. You want sebum on your skin, but not too much of it. If you got too much of it mixed with cellular debris, it clogs your pores and gives you acne. However, in the right amount, when you keep your skin clean and your hair clean, it keeps your hair and your skin nice and soft and youthful. Keeps it from getting wrinkly, and it keeps your skin waterproof. The sebaceous glands reside on the sides of the hair follicle. Like I said, acne is caused by overactive and inflamed sebaceous glands. So going to your picture, the sebaceous gland is next to the hair follicle. So right here, you have the sebaceous gland. So it's up closer to the epidermis. So it produces the sebum. The sebum just kind of comes up through next to the hair. All right. Next one we have is the sweat gland. There's another term for the sweat gland. Oh, yeah, your picture calls it the sudoriferous gland. Sudoriferous gland. You need to color that tan. It's a ball-shaped coil in the deep dermal layer with sweat-secreting epithelial cells. This tube extends to the surface as a pore. So really, it's one really long tube that gets coiled up into a ball in the dermis, and then part of the tube goes up into a pore in the surface of the skin. It's an exocrine gland. It produces sweat. Your sweat is mostly water with some salt and waste. And some of those wastes are urea and uric acid. So some of the same wastes that you have in your urine as well are in your sweat. It's an eccrine gland, the most numerous type of eccrine gland in your body. It's all over your body. It's going to respond to your body temperature, but it also responds to emotions as well, releasing sweat. Oh my God. Okay, the kinds, okay, I'm looking ahead here. Like, there's different types of sweat glands. There's one of them is eccrine glands that only responds to heat. When you get too hot, you sweat. Let's go back to the picture to show you the sweat gland. Here's a sweat gland. It's coiled up into a ball here, and the tube comes out, and there's sweat on the top. Another type of sweat gland is, drum roll, the apocrine gland. The apocrine sweat gland. That one becomes active at puberty. That one secretes sweat in response to emotional upset, fright, and pain. The most numerous apocrine sweat glands are in the axillary region, the armpits, the groin, and the nipples. And your mammary glands are another type of sweat gland. It's a modified type of sweat gland. It's not going to produce sweat. Obviously, it produces the milk, lactose. Here's an image of the sweat gland. Another one shows a coil. This is if you took this coil, cut it in half, and looked at it from the side, you would see these glands. So these look familiar to you. Look like simple tubular cells. Another accessory organ here is nerve supplies. So usually those are going to look yellow in the picture. So I'll go ahead. There's all these nerve supplies here in yellow. And each one of them has an ending that are called corpuscles, or nerve terminal would be the ending of the nerve. Very abundant in the skin. And we're going to do a lab on that so you can see some parts of your skin have more nerve endings than others, because some areas of your body need to touch more things than other areas of your body. On average, though, you have about 1,000 nerve endings per square inch of skin. Make sure you color those in your picture. No, I don't see them in your picture. But as I'm looking at your picture and you see you need to color in the stratum germinative green. That would be the bottom part, or thinking stratum basal, so the bottom part of the epidermis. You need to label the epidermis, that top little bracket on the top, label out the epidermis. The stratum corneum should be pink, so that should be the top layer, the top surface of the epidermis, so that's pink. The papillae, or papilla, is that ridge, so the ridged area should color red. Subcutaneous layers, that fat on the bottom, those little circles, those should be colored yellow. Talking about sebaceous glands should be orange, hair root purple. All of the dermis area in between there, in the middle, should be colored gray. Go ahead and label that second bracket dermis, and then label that bottom bracket hypodermis. Okay, going back to your nerve supply. I'm sorry. The nerve terminals are abundant in the skin. I said that. Okay, corpuscles is a fancy name for the nerve endings. They're encapsulated with connective tissue. There's two types of nerve endings: Pacinian corpuscles and Meissner's corpuscles. You'll need to know the difference between them. So all these are underlined so they will all make good flashcards. Pacinian corpuscles respond to deep pressure. So when you press something deep, so these are going to be deeper in the skin, and then Meissner's corpuscles are touch receptors. They're going to be more shallow. I'll show you on this next picture here. Meissner's corpuscles are up here on top. These ones down here are Pacinian corpuscles. Meissner's are shallow. Deep is the Pacinian. So P, Pacinian, and P for pressure would be deeper. And I think that's where we're going to stop here.